research. I'll tell you briefly about each of the students. Lucy is currently a sophomore at Brevard High School. This is her first year in the time program. She's interested in projects related to conservation and green innovation. She participates in other clubs at Brevard High School, including the Student Council and the Interact Service Club. Outside of school, you can find her running cross country or track, or just enjoying time outside. She plans to attend a 4-year university and major in science. Andy, or more officially Anderson Mckibbon, is a senior at Brevard High School. She's been involved with the time program since her freshman year, so this is her 4th year in the program. She's done conservation-related science for her larger time projects. She also runs track and field year-round and also participates in student council and is involved, as many of our students are, in a handful of other clubs in and outside of school. She spends time volunteering for the Wildlife Transylvania Youth Club, the Jam Music Program, and El Centro. She says she hopes to actually switch her interest from science to pursue a degree in international relations in Spanish. She's in the process of hearing back from schools, but has not yet decided what university she will be attending. So this presentation they will be giving, I hope they will also be presenting at the North Carolina State Science and Engineering Fair, I believe next month. So with that, I'm going to let them give their presentation, and they, of course, will be happy to answer your questions at the end of their presentation. And then stay tuned because we have a second presentation by Bill Brady. But let's start with Lucy and Andy. It's all yours.
Okay, I'm going to go ahead and share my screen.
One second, Lucy.
Okay.
Okay, I'm good to go.
All right, cool. Can everyone see my screen?
Yes, it's coming through fine.
Yes, I can see it fine.
So for our research project, we did an analysis of change in songbird mist net captures and overall bird density between 2008 and 2019 at Big Bald Bird Banding Station and the Greer Doppler Radar Tower. I'm Lucy Murray.
And I'm Andy Mckibbon. So looking at some of our key terms to begin with to keep in mind throughout the presentation, we're looking at a mist net. Mist nets are a transparent mesh net used by ornithologists and other trained professionals to capture birds. A bird banding station, generally these stations are known locations that see a lot of bird traffic during migration, but they often set up mist nets and other observation-based tools to capture, identify, distinguish, and track birds passing through during migration. Birds per mist net hour is one of our main units used in our study. The total number of birds divided by the amount of hours the nets were open on that specific banding date. So for our background information.
So looking at the environmental impact, obviously, as you know, birds play a very important role in every ecosystem, but specifically looking at the songbirds that we wanted to study in our study. They serve the role in the ecosystem as pollinators. They also help disperse seeds through their waste, and they also help to manage insect populations. And we are wanting to look at the impacts of climate change on the songbird population. So there are factors that relate to this, like the loss of their habitat throughout the world, and also the interruption of their phenological patterns. So essentially their migration patterns through warming temperatures, which are doing things like pushing the migration dates forward and changing the length they migrate for, really affecting a lot of different factors. And so for our research, we wanted to correlate this on the ground banding data and this Doppler data to get a very concrete and clear idea of the migration patterns and of the population of the songbirds coming through this area. So if we have this really concrete and clear evidence, we have a really strong base to compare that to other factors that are going around that might be affecting the migration, like as we mentioned, the loss of habitat and the global warming.
So we were focusing on looking at changing migration patterns, as Lucy mentioned, due to climate shifts and habitat loss seen in the past several decades. According to another North Carolina bird migration study, May North Carolina migration season for the fall is August 17th through November 1st. So we worked within those dates for our study. The study also mentioned the fall migration showing more traffic on the coast of the state versus the spring migration being more concentrated in Western North Carolina. So Big Bald Bird Banding Station was our selected banding station for the project. It is located in Mars Hill, North Carolina, about an hour and 45 minutes northeast. The banding station sits up on Big Bald on the Appalachian Trail. It has open bald with some dense wooded forests, making it prime for not only songbird stopover habitat, but also raptor watch. This is also represented in the sheer volume of birds coming through the station pretty regularly. The station was gracious with their data, giving us extensive access to the past 10 years, falling in line with our study period.
So here on this map, we just wanted to give you an idea of where everything is located related to Brevard. So as you can see, Brevard on the map, it's right here. And then Greer Doppler radar is just located in the Greenville and Spartanburg area. That's just the weather radar down there. And then Big Bald Banding Station is on the border with Tennessee, but again, located near Mars Hill. And so here we want to talk a little bit more about our trip to Big Bald Banding Station. During our study, we were lucky enough to get to go and visit and kind of almost help out for a day up there. So as you can see in this picture down here, the Bald is very open and you get a gorgeous view of the mountains, and you pop off on a little side trail and you come into this kind of little nook in the forest, and they have this banding table set up, and here a certified ornithologist will actually band the birds, and you can see a data collector uses their iPad to insert all of this data into the iPad and Google spreadsheets, which the spreadsheets are ultimately what we got all of our data from. And here you can see getting one of the birds from the mist net. So as you can see, the mist net is pretty thin, but it's also relatively tall. I'd say like 6 to 7 feet tall, but it's right in along with the trees. So the birds really don't know that's there. And they just get tangled in it, and you go through and untangle the birds from the net. And they have over 20 of these mist nets at Big Bald all throughout the forest, and you just kind of go through on these little trails that wind through the forest, and you can collect the birds, and we put them in these brown paper bags that would be labeled so that the bird bander back at the banding table would know which ones to do first, maybe based on behavior patterns of that bird. And once at the banding table, the bander would band the bird and list off a series of data points pretty much about the bird. So stuff like wingspan, age, gender, progression of the molt, just stuff like that you can tell pretty much by just examining the bird. And then once it was banded, we let it go. And I think the day we were there, they had over 50 birds. So there is a large volume of birds coming through a big banding station. It really is a prime habitat for the songbirds.
So we mainly focused on songbirds, mostly because those were the group of interest, but also to control our variables throughout the experiment a little better. In doing this, we were just working with birds migrating at night, meaning that our Doppler radar scan was taken at night, and we used bird banding data from the corresponding day. These songbirds generally have high altitude flights compared to their normal activity from 500 to 1500 meters up in the air. In addition, looking at their stopover habitats, songbirds prefer dense, kind of wooded, ecologically rich places, falling in line with our chosen banding station up on Mars Hill. So some of our most popular songbirds that we saw in our data and on our visit We narrowed it to 3 guilds: the warblers, juncos, and thrushes. In this picture, we have the Tennessee warbler, the slate-colored junco, and the wood thrush, some popular visitors at the banding station, and some frequented birds in our data.
So to look a little bit more at our project, we did a radar ornithology project. So this basically is exactly what it sounds like. We are using radar to study birds. We are specifically using a NextRad radar, which just stands for Next Generation Radar, and I'll talk a little bit more about that on the next slide. But the data point we were using was reflectivity. And from these reflectivity scans that we would get from the radars, we can determine information like velocity, altitude, and most importantly for our study, density, so birds per centimeter squared per kilometers cubed. And on this little map at the bottom, each of those little dots represents a weather radar, and you can see those little circles flaring up around them. That's kind of what the birds look like as they pass through that radar scan. So a little bit more on the Doppler radar. Again, we are using NextRad radars, and this gives us radial velocity. But most importantly about the NextRad radars is they have the dual pole update. So this actually provides us with a 2D image, because this radio wave, you can see here at the bottom, was sent out both vertically and horizontally. So that gives us a really clear and concise picture of the bird cloud in the radar scan. And we get these reflectivity units basically just based on how strong the reflection is. So whenever this radio wave goes out, it bounces back against the bird cloud, and based on how close it is and how dense the bird cloud is, it gets a reflectivity reading that we can see pretty clearly in the radar scans provided through the NOAA climate toolkit.
So for literature review, in 2016, Bueller and others began to monitor the development of different stopover habitats of migratory birds in North Carolina. They utilized the NOAA Doppler data as well, similar to our study, but their intention was to predict future stopover adaptations and habitats of these migratory birds. In 2008, Gastran and others compared the effectiveness of 2 different radars, the bird radar and the C-band Doppler radar. They found when they were used together that there was peak accuracy, although between the two, the C-band radar was overall the more efficient. And that is the radar implemented in the NextRad Doppler radar used in our study.
Arrival of peak migration in the autumn migration season. And now for our question, we asked, does the analysis of Greer Doppler radar reflectivity data from 2008 to 2019 show a change in the arrival of peak migration and a decline amongst migratory birds? And does banding data from Big Bald Banding Station validate that change?
So we hypothesized that the data from the Greer Doppler radar and the banding data from the Big Bald Banding Station throughout the years 2008 through 2019 show an earlier arrival of peak migration and a decline in the density of migratory birds. So to begin our methods, we began by downloading the NOAA National Oceanic and Atmospheric Administration Climate Toolkit. From there, we selected our chosen radar located in Greer, South Carolina. Following that, we adjusted our settings so that we were only viewing the reflectivity scan, and we set our elevation angle closest to 1.5 for the most effective angle for viewing the bird density.
And then looking at our sampling days throughout the 11 years, 2008 through 2019, again, we're using that peak fall migration season. So that's from August 17th to November 1st. And because of time constraints on our project this year, we looked at 4 years evenly spread out throughout the 11 years. So 2008, 2012, 2015, and 2019. And within each of those years, we chose 10 days per year where there was no weather or precipitation on those days in the radar scans. And also we needed days that there was banding data. So things that might mess with the availability of banding data is if there was a particularly cold or windy day where it just would not be suitable to have the nets out. And then we also, for those reflectivity scans, took a reflectivity snapshot at 8:30 p.m., 1 a.m., and 4:30 a.m. And those times in the a.m. were from the following morning.
After we had selected our dates, we began to gather our reflectivity data. We went through the process of exporting our data to a CSV file in Excel, and then computed those values to our final reflectivity value of centimeters squared per kilometers cubed using the formula below. And the image below is just kind of showing the computing process in Excel.
So now to look at the banding data, again, we're using that unit birds per missnet hour, and we have the same dates for each year. The dates were not consistent throughout the years, but within the year, the 10 dates were the same for both the banding data and the reflectivity data. We also collected data specifically on warblers and thrushes to see if one of those guilds maybe had a significant impact on the decline or increase or whatever patterns we saw in the data. And then we use the Excel analysis tool pack to run a single factor ANOVA to look for a decline in birds per missnet hour and reflectivity. And those analyses were run separately. And then lastly, we used a linear regression analysis to correlate birds per missnet hour and reflectivity data. And now to look at our results. So here's our linear regression analysis. As you can see, there is little to no correlation. Our coefficient of determination is essentially 0. And down here on the bottom of your screen, you can see our coefficient of correlation is actually slightly negative, but again, pretty close to 0. So no significant numbers on this graph. And now this is our analysis of variance for the reflectivity data. You can see we have our groups are the 4 years, and the count within each of these groups is 10, representing the 10 dates. So we ran this through the Excel program and we got out our p-value of 0.09, and we were comparing this to an alpha level of 0.05. So if the number that, or the p-value we got rather, was less than 0.05, we would have determined that the difference between all of these 4 years was statistically significant, and we would have had to do further research on whether there was evidence of decline or an increase that caused that difference. But because our p-value was greater than 0.05, we did not do those further investigations. But considering this is an ecological study and you can't really control your data since we are working with nature here, it's a pretty impressive number that we want to share.
So looking at birds per missnet by year, this graph represents just our banding data and birds per missnet hour units compared to our dates, mainly looking at the change in bird density. Although these results do not support our hypothesis of a decrease in bird density, we do see a relatively significant increase over the course of 4 years, which we theorize could be in line with our initial reasoning of habitat loss, and that the rich habitat offered by our chosen banding station created somewhat of a funnel, and as habitat loss increased, so did the amount of birds coming through that specific area. Reflectivity by year, this was one of our most significant results, representing just our reflectivity values against the dates, mainly investigating the arrival of peak migration. The blue dot represents our first year, 2008, and its peak, and the green dot shows our 2019 peak. As you can see, there is pretty consecutive movement over the 4 years to show an earlier arrival of peak migration. These results supported our hypothesis and show a very distinct and consistent change in the migration patterns. We believe, in agreement with our hypothesis, that this is due to a warming climate, moving fall migration earlier and earlier each year. For our discussion, one of the first issues we came across was precipitation in our radar scans. Due to the fact that we aim to only download reflectivity, we could not get any clutter in our final export. So this left us with inconsistent dates, meaning we didn't use the same 10 days every year because weather did not permit, but attempted to keep them as similar as possible. The next issue we noticed was that Big Bald Banding Station was located in a prime habitat. And as I talked about earlier, we believe that this may have created some sort of funnel, which may have skewed our bird banding data to be higher than anticipated. We also saw some outliers in our banding station data. We think that this is because there were a handful of dates that had significantly low net hours. So when divided with the birds, they produced very large values, skewing our data. We only noticed this after the fact, but would attempt to completely cut out those outliers from future research.
And now moving on to our conclusion. Again, as you saw in that one graph, there's little to no correlation in our linear regression analysis comparing the birds per missed net hour and reflectivity data. And through the ANOVA and those smooth graphs, you can see that there's no significant evidence of decline over 11 years. However, as that one graph that Andy walked us through,
Andy, maybe,
pattern
okay.
in the
Lucy, we can't hear you.
I
I can hear you now.
you can?
Yeah. So maybe just start at that last point.
Okay. And for our last point, looking at that last smooth line graph, you can see the consecutive reflectivity change, again, looking at that peak migration moving earlier and earlier each year, as Andy pointed out. However, that same pattern was not represented in the Big Bald Bird Banding Station data.
So for some possible future work, we think that looking at several different next generation radar locations and different bird banding stations could increase accuracy and validity in our results. We also thought that some sort of automated correlation program, automatically pairing some sort of on the ground data, whether that's citizen science or banding data like we were working with Doppler radar, could be pretty innovative technology. So.
And finally, for our acknowledgements, Dr. Sid Gotri, as you saw, who joined the call. He was a great mentor in this project. Andy's mom, Dr. Mariah Whitehead, also offered her thoughts and helped us a lot with the project. Our time peers, Miss Williams, and finally, Mark at Big Bald Bird Banding Station. Any questions?
Yeah, this is
Go ahead,
Tom.
Tom.
Yeah, I'm curious just because weather is changing, the weather patterns. The earlier departure days to come north, do you know, and I realize your study was a very finite fixed one, was weather in Florida or wherever they come from a determinant in when they left, or was it the reception weather of here when they got here? How much did weather play into this? And that may not have been a purview of what you looked at.
So we were just kind of hypothesizing that the warmer climates up north were pushing the birds down south earlier than usual. So we believe that it is an effect of the climates being warmer up north, but we didn't really go in depth on that. That was just somewhat of a hypothesis.
Thank you.
I noticed in your reflectivity graph, there were 2 peaks for each of the years. And I'm just wondering, would that have been 2 different species that were migrating that represent those 2 peaks?
We did not have time to investigate that further, unfortunately, though we did notice that pattern. And you can also see, I think maybe even a little bit in the banding station data, there's also, you can see kind of around here, not as significant a peak, but that does kind of move up again towards the end. So we're not sure if there's maybe a specific species that is traveling a little bit later, or if maybe these reflectivity dates, for whatever reason, really did have significant values in them. But as you can see, since we only looked at 10 days throughout the year, these really are just like one value and one date that are dragging these peaks up. And so I'm not sure if we had looked at more dates, if those peaks would still appear as significant or not.
Lucy and Andy, this is Sid Gotro. I have a question. You sampled at different times during the night. What did the reflectivity values look on average for those different times you sampled during the night? Can you say what portion of the evening the majority of birds were moving?
Yes, so we did an average of all of the times and an individual time. We ended up with just going with the 1 o'clock time because that was the highest out of all of the dates. So our 1 a.m. time produced the most reflectivity of all 3 times.
Okay. And the reason I asked that question is that birds departing from your area around the banding station and the radar would take place early in the evening, but birds after midnight would start landing. And so the latter part of the night would be when you expect the input of birds to your banding station. So that's why I was asking to see if the amount of movement early in the evening, how many dates you had that relative to how many dates you had some of the biggest numbers coming in after midnight that would come into the banding station.
Our 8:30 times were exceptionally lower than 1 a.m. and 4 a.m. So we saw just very large differences in the earlier night reflectivity values versus 1 and 4 a.m. being a lot more compatible.
Okay. All right. Thank you. Very nice presentation. Both of you have done a very, very nice study, and your delivery has been outstanding.
Thank you.
Thank you.
Any other questions?
I'll throw out another one to you too, and I think we discussed this before. Is there a problem trying to correlate MISNet data that's gathered during the day with reflectivity data that's gathered during the night?
We specifically tried to time the dates that we were using. So each of the paired dates, so those 10 days throughout the year, the banding data that we were using, we always made sure that was from the day before the night where the reflectivity was, when the reflectivity was collected. So trying to mimic the birds being at the banding station and then flying south during their migration. And specifically talking about like the birds and the misnets being songbirds, we touched on that a little bit on our songbirds slide, I believe. But songbirds are the majority of the birds making up that radar scans that we collect, just because they do migrate at night, and the altitude we were using was specific for the bird clouds of songbirds.
So, and a follow-up to that, as we'll hear shortly, there are some birds, particularly hawks, that tend to migrate more during the daytime. Could you do the same study with reflectivity data from the daytime?
I think potentially, because there are radar scans essentially like I think every half hour provided by the NOAA Climate Toolkit. So I do think that would be interesting to do. Not sure if we would get a large enough bird cloud during the day, or if it would be or have too much clutter rather than just the raptors passing through. So that would be interesting to look at.
Any idea about how many birds it takes in a flock to give reflectivity data? Are we talking 50 or 5,000?
Yeah, I think Dr. Gosher might be a better person to answer that question.
This radar is incredibly sensitive, and I think that it's sensitive enough. We can measure that. There's a formula called the radar equation, so you can actually back calculate how far away you can see a bird of a certain size. And this radar is sensitive enough to pick up something like a warbler, probably 50, 60 miles away, a single warbler. So the fact of the matter is I don't think sensitivity is an issue. What is an issue, and my current study right now is developing a way to get rid of this particular issue, and that is during the day, for instance, a lot of the reflectivity we're getting in the atmosphere, in addition to some birds, is produced by insects in the atmosphere. A tremendous amount of insects would produce reflectivity comparable to a reasonably strong rain shower. So you have to come up with some method of eliminating insects if you're going to look at daytime migration. The same thing is true to a lesser extent at night, but there are nights where there's very little bird migration and lots of insect movements, and that's always a bias in studies like this. So if you can eliminate the precipitation, you can eliminate the insects, then most of what's up in the atmosphere would be migrating birds and, of course, some bats. And it's almost impossible to discriminate migrating bats from migrating birds. So to answer the question, yes, you could do this in the day, but you'd have to filter the reflectivity data to get rid of the insect contamination.
Thank you very much. That was an excellent answer to my question. Before we go to our next speaker, I want to be sure that all of our guests have had an opportunity to ask their questions. Don't be shy. Any questions you can direct to our students now will really benefit them when they compete at the state and maybe even at the international level. Thank you, Abby. Abby says, great job, Andy and Lucy. Okay, I won't hold you anymore. I know you have classes to attend. So Andy and Lucy, thank you very much. Excellent job. Really appreciate your participating.
Thank you.
Our next speaker, yeah. Okay, our next speaker is Bill Brady, who is retired, lives in South Carolina, and spends his fall days out watching hawks as they migrate over Caesar's Head and Sassafras Mountain. So Bill, tell us a little bit more about watching birds migrate during the day rather than at night.
Can everyone hear me?
Yes.
Yes.
Okay.
Yeah.
I'd like to thank the students there. They did a great presentation, and to answer one of the questions, they actually use radar for migrating hawks in the day down near Charleston. At least they had in the past. But I'll move on. So everybody can hear me. I want to say one thing, that one of the things I'm going to talk about is general hawk watching, but I want to be sure that most everyone is familiar with Sassafras Mountain and Caesar's Head. I assume most everyone is, because I'm going to be talking a lot about both locations. First, I'd like to define what a hawk watch is. A hawk watch can be defined as persons observing migrating raptors, and in most cases recording the species, flight direction, date, time of day, and even weather conditions. We also record who is participating and the location of the observation. Some hawk watches use more than one location depending on conditions. The birds we are counting are in flight as compared to seeing birds in trees, on local lakes, or feeding in our backyard. At our watches, we count hawks, eagles, falcons, and vultures as they migrate through our locations. At Sassafras Mountain and Caesar's Head, we do the fall migration from Labor Day to the end of November. There are places in North America that do it in the spring, and I've been involved in at least one of those. How do we know where and when to do this? Well, someone in the past has seen migration at this location and let others know about it. A perfect example is how things got started at Caesar's Head. A park ranger in 1980 saw hawks passing over the overlook, and soon birders created a Caesar's Head Hawk Watch. Those involved were posting findings on a national website so others could see the results. Some of the helpers at Caesar's Head lived in Pickens County, and back in 2014, they saw many hawks on Sassafras Mountain after the trees were cut down. We at Caesar's Head always saw these raptors during the fall migration in the western sky, and this piqued our interest. In 2015, one of the experienced Caesar's Head observers named Ed Moore created the Sassafras Mountain Hawk Watch. I went over a few times that year, but when other experienced counters like Elizabeth Galloway from Brevard also joined in at Sassafras, I decided to keep the Caesar's Head Hawk Watch going so we could see what was migrating through at both sites. You may ask, how do the observers know what kind of raptor they are seeing, and how do they know the bird is actually migrating rather than a local bird? My suggestions are that you work with an experienced observer and learn how to ID these birds in flight, which is totally different than looking in your yard and seeing that bird in a tree. Each species has a unique coloration, wing shape, flight characteristics, size, and timing during the fall migration. And that falls in line with what was discussed a few minutes ago. We have peaks during the migration where we see broadwings coming through at one time and large groups of turkey vultures and black vultures coming through at a totally different time. Also, to help you out, bird books, videos, and publications can all help to identify these species. Most migrating raptors do not stick around long and are only seen for a few minutes or even seconds compared to the birds you might see around your yard or farm. A trained observer has to consider if they see raptors that might be in the area but not moving on. We call those birds locals. That bird may stick around for a while and then take off, and then he might come back, who knows? A trained observer, songbirds and non-raptors are noted, but is not the main focus of the Hawk Watch. Some locations in North America see hundreds of thousands of birds and do record those numbers. We at our two locations do not see that many songbirds, partly because they do migrate at night, but we do know what we do see. Who are the persons doing this counting? That would be anyone that is willing to be at these watch locations long enough on a given day to see birds migrating and help to record this. Certainly a large percentage of these people are retirees since they have the time it takes in the spring or fall to participate. Most people that help at Sassafras or Caesar's Head drive a good distance each way and spend 4 to 6 hours each day counting. Other locations nearby in the Appalachian Flyway that do similar raptor counts are at Mills River Overlook on the Blue Ridge Parkway, as most of you are probably aware. Grandfather Mountain, Lenore, North Carolina has a watch at a school, and Pilot Mountain. We can look at each other's observations daily on the Hawk Migration Association of North America website called hawkcount.org. I'm going to discuss that same website several times. There are hundreds of hawk watches that report on this site in the spring and or fall. I do not know of any sites locally that count in the spring, since we believe most of the birds travel up the western side of the Appalachians on their way back north. Some raptors may come through here in the spring, but in very small numbers. There are other hawk watch sites in South Carolina that are in the coastal flyway. They probably see more waterfowl and coastal birds than we would at Sassafras or Caesar's Head. The website hawkcount.org lists all the participating watches by country, state, and location. What I mean by that is that we have people that count in Central and South America and Canada, just like we do in the United States. The observers at all sites take the information from their worksheets or on their phones, and that's a new technology, and post this on the website, so the website becomes a history for each site for years to come. There are more than 100 very active hawk watch sites in North America and South America. The website is open to the public, so anyone can see it. Of course, the perfect situation is to have several observers each day with perfect weather and birds over both sites all day. We know only too well that does not happen. As discussed a few minutes ago in the students' discussion, you have to be there to count them. And weather does affect us with fog, haze, tropical storms, local rain, and in November, colder temperatures. As examples, the distance and geography between Caesar's Head and Sassafras limits what we can see. As an example for the need for counters at both sites, one day several years back, I was at Caesar's Head and only counted 37 birds when I got rained out about 1 o'clock. While this was going on at Sassafras, Ed Moore had counted hundreds of birds, mainly broadwings, every minute until rain made him close up his watch. Every day is totally different, and that's true of every site. At Caesar's Head, it's difficult to see back to the north because the trees behind the overlook. Conversely, at Sassafras, we can see birds coming from Sugarloaf Mountain, from Caesar's Head, from trees where they're roosting overnight. We can see them coming from Brevard, etc. Some days in November, there's hundreds of turkey vultures that come from Mount Pisgah, gliding down to circle over the observation tower at Sassafras. There are days we see large numbers of birds coming from the Broad River Valley from Brevard or very high over Toxaway Mountain. The raptors we are counting are bald eagles, a few golden eagles, kestrels, falcons, Cooper hawk, red-tailed hawk, sharpshins, turkey vultures, black vultures, red shoulder hawks, osprey, merlin, and harriers, but the most numerous we see are the broadwing hawks that use the thermals to guide them from northern US and Canada to Central and South America. As an example of that, Hawk Mountain did a study where they banded birds and they went all the way to Peru. Most hawks and eagles do not migrate, excuse me, but not all of them do. Some may travel just as far as they need to just to get food and a safe place to stay. But the majority travel thousands of miles, usually following a path other birds showed them in years before. Next, I'm going to list a few examples of what has been seen at various sites in North America, just to show you some examples of the counts. In Duluth, Minnesota at Hawk Ridge in 2020, they counted over 62,000 raptors come through. 1/2 of them were broadwings. 5,300 were bald eagles and 13,000 were sharp-shinned hawks. Another example, Cape May, New Jersey in 2020, they counted over 31,000 raptors. 1/3 of them were broadwings and 27 types of sea or shore birds. In Ontario, Canada at Holiday Beach in 2020, they counted 115,000 birds. 55% of them were broadwings. An example of other birds they counted over 1 million blue jays and over 15,000 crows. So those were birds that migrated during the daytime. At Hawk Mountain, Pennsylvania, which is the granddaddy of the hawk watches in 2020, they only counted 13,000 birds, and only 1/4 of them were broadwings. Their annual average runs between 12,000 and 25,000. I have to attribute, since I had looked at their sites, the low number was partially due to the weather. Sassafras Mountain in 2020, we counted 8,651 raptors. 3,500 of them were turkey vultures. Again, our broadwings came through in September, and most of the turkey vultures came through in late November, mid-November. The highest amount we've ever counted at Sassafras is 11,641. The lowest is 2,867. And that was the year there was a fire at Table Rock, and we also had some tropical storms. In Caesar's Head at 2020, they only counted 1,200 and some birds, but partially because they did not count as often due to the COVID situation. The highest count they ever had at Caesar's Head was 13,425. In one day, in 2013, they counted over 11,000, but that was over 8 hours with 8 to 10 people counting. Let me discuss what we've done with the COVID situation. At Sassafras Mountain in 2020, we established a portable rope fence at the ground level and used signs to keep us separated from the visitors when we had more than one counter on site. We created these rules based on what the hawk migration in North America called for. Inside the fence, we wore masks and tried to social distance. As the season wore on in October and November, we had less counters, and each of us would decide what was the best based on crowd size and social activity, although we kept the masks and our fence handy as needed. At Caesar's Head, due to COVID, Tim Lee, the ranger and site coordinator, asked me not to count in 2020, but he and a few others did count a few times, mostly at a private site. Caesar's Head overlook was just too small when all these visitors would come through up there. Some sites in North America actually did not count at all in public due to the COVID restrictions. I'm going to tell you what we have questions visitors ask us at all these sites. How do you count thousands of birds in one day? My answer is we count over 6 to 8 hours. We have multiple counters. We compare our counts before we post it, and we use handheld counting devices when needed. The next question usually is, when do these birds come through? What time are they going to be here? Well, if I knew that, I'd have a lot of money in my pocket. The main answer is we follow the migration history. We also look at the sites north of us as they're coming through on the hawkcount.org website. How many hours do you count? Weather affects what we do, but we usually plan 6 to 8 hours. How do you know birds are migrating is a big question. Well, if they come through and they keep on going, they're usually migrating. We do have some locals, as I've discussed. Where do birds go? As I said earlier, they go into Central America. Some go just to the coast of the United States in the coastal area. It just depends on the type of bird. Before I finish up, I'd like to invite anyone in the Zoom meeting to attend a watch we do or any others. If you're going to do that, you need to bring proper clothes for the season, good binoculars for seeing birds at long distances, sunscreen, water, and plenty of patience. Spotter scopes do help in certain situations. Looking at hawkcount.org will help you see what is coming our way by checking, in particular, the site at Rockfish Gap on the Blue Ridge Parkway in Virginia. They are usually 2 to 3 days ahead of us. We might see and have on certain years seen what they are actually seeing almost to the number. One of the note as we do count monarch butterflies. We started that a couple of years ago. I have been on the Transylvania Bird Club web page, and if those members are listening, I'm very impressed with the variety of species recorded. I need to come up there and check out some of the sites. If interested in planning a few hours hawk watching the Sassafras Mountain or Caesar's Head, let us know to make sure that someone will be there. In the last half of September and early October, someone will probably be there since that's the peak of our migration. Right now, all we can do is hope for the ability to do our watches this fall with the COVID situation. Ken and Kent both have my email address, and Ed Moore's email address is on the Sassafras site on hawkwatch.org under site description. Is there any questions?
I'll make a comment before anyone else asks questions. Something that I've learned both from reading more about Hawk Watch and also listening to the students' presentations. So hawks and in general predatory birds prefer to migrate during the day because they've got to be able to eat So they're looking for mice, rodents, and anything else they can capture in daylight hours. Songbirds obviously don't want to be in a big flock mixed in with hawks, so songbirds, to avoid getting eaten by the hawks, tend to migrate at night. So there is sort of a partitioning based on diet and predators and prey that determines when these birds migrate. I thought it was pretty interesting. Are there any questions for Bill?
Bill, it's Ken Kynard. Is it really that much of an advantage to have the 10 power binoculars for the hawk over 8s? I noticed you had 10 powers when you were up there. Does it make a great deal of difference?
I'm going to answer yes. Most of the people there have 10 power. We do have people that bring spotter scopes, and they do help under certain situations. A good example of that was at Caesar's Head. We had a member come and he kept an eye on what was in the western sky towards Sassafras, that we could see birds out there but couldn't identify them. The spotter scope really helped. But 10 power usually is what most of us use. And the situations are when you're doing the hawk watches, sometimes those birds are right on top of you, and sometimes they're 4 or 5 miles away. So it's a difficult answer to give you.
Thank you. I had the opportunity to do it last year, and it's really a fascinating thing to be up there on Sassafras Mountain, and all of a sudden a group of raptors just appear in the sky. It's a lot of fun.
Yes, I did a hawk watch on Lake Erie, and the birds were only there for maybe 4 or 5 seconds. The wind is pretty intense going west to east at the bottom of Lake Erie, and they come over you very fast. Where at Sassafras, sometimes you have opportunity to see them for a longer time.
Bill, one species that I haven't heard people mention are owls. Do owls migrate? If so, do they do it in flocks? And do they migrate by day or by night?
I was just reading about that, and they probably do migrate to a certain degree as they need to. And I'm going to say that they probably do not migrate in large groups. And I've never encountered an owl migration.
Just wondering, a few years ago, we had a snowy owl that landed in Transylvania County for a while, and there's always interest when these sort of different species show up in our county.
Yes, my brother's with Audubon in Pensacola, and he flew all the way to my sister's house on Lake Erie to see the one up by Buffalo. So I understand, but I don't think they travel in large groups.
Okay, thank
Bill,
you. Any other questions for Bill?
Yeah, this is Sid Gotro. Can you hear me?
Yeah.
Yes, go ahead.
Just a comment about the radar in the low country. That was a marine radar that I started using at the Birds of Prey in Orndorff, South Carolina on the coast. They had a long-standing raptor migration count program. And I wanted to see how those numbers compared to numbers if we could cue hawk watchers in to echoes on a marine radar screen as they were coming towards the hawk watch point. And it substantially increased the number of birds that were detected because you knew where to look in the sky relative to where that echo was moving. The problem is, of course, in hawk watching, you're not going to be able to compare those results directly with the results where they're not having radar, because the radar is biasing the counts much higher than the hawk watchers get without the radar. But it does show you that even though we have a lot of observers, we're still missing some of these raptors that are coming over. And the question there is just what percentage. So the radar helps in getting some base data like that to know what you're missing, but it's not widespread using radar to monitor raptor migration. My study with weather radar, as I said when Andy and Lucy were presenting before, During the day, you have lots of biological scatterers in the atmosphere, mostly insects. And for instance, at places like Corpus Christi, where there are just incredible numbers of raptors migrating through that hawk watch area, we have to basically filter out all of the return coming from insects in order to have the return from the raptors on radar. And I'm glad to say that we can actually do that now, because the radars in 2013, the weather radars were upgraded to dual polarization. That is, they simultaneously transmit horizontally polarized and vertically polarized waves. What that allows us to do is to actually filter some of those biological scatterers in the atmosphere, and it allows us to get rid of insects and leave basically bird scatterers up in the atmosphere and on the display. So that with this advancement in technology, I think we will start to be able to use weather radar to at least indicate how big a raptor migration is taking place over certain areas.
Yes, the Corpus Christi watch, they see a tremendous amount of kites, Mississippi kites come through there. Probably
Yes.
more than any other bird. I think they also have a radar at the site down off 17 below Charleston. I think it's an old Navy radar. I might be wrong.
I have been using radar here on Edisto Island. That is part of my research radar, marine radar, and quite frequently pick up movements of red-tailed hawks and turkey vultures in the spring, but it occurs fairly early. A lot of these raptors start moving north surprisingly early compared to a lot of the songbirds and the like.
Correct. As Tim Lee at the Caesar's Head says, it's a race to get back to do your breeding back in the north.
Yeah, the breeding imperative.
Yeah.
Okay, I think we've had two great presentations. I want to thank Bill Brady for his presentation. I want to thank Dr. Gothrow for joining us and adding some perspective to our presentations about bird migrations. But I think we've got a fairly long business meeting potentially coming up. So thank you. Everyone is welcome to stay for the business meeting. We are open.